Good morning. আজকে আমি পাওয়ার সিরিজ সলিউশন অফ এ ডিফারেনশিয়াল ইকুয়েশন নিয়ে কিছু ডিসকাশন করব। Today we will discuss about power series solution of a differential equation. First, what is differential equation? Differential equation কি? Differential equation are equations with derivatives of first order, second order, third order. There are two types of differential equation, ordinary differential equations and partial differential equation. Ordinary differential equation has dy dx, d2y dx2, d3y dx3, etc. And partial differential equation means del del x of z, del del y of z, etc. etc. Means here we have to solve differential equation in the form of power series. মানে আমরা জানি যে ডিফারেনশিয়াল ইকুয়েশনকে আমরা যখন সমাধান করি তখন আমাদের একটি সাধারণ সমাধান আসে। সাধারণ সমাধান অর্থাৎ জেনারেল সলিউশন। Solutions are known as general solution if it contains the equal number of independent variables as the order of the differential equation. অর্থাৎ একটি ডিফারেনশিয়াল ইকুয়েশনে যতগুলো একটি ডিফারেনশিয়াল ইকুয়েশনে ঠিক যত অর্ডারের হাইয়েস্ট ডেরিভেটিভ উপস্থিত থাকবে তার সমাধানে ঠিক ততগুলি স্বাধীন আরবিটারি কনস্ট্যান্ট থাকলে সেই সমাধানটিকে আমরা জেনারেল সলিউশন বলে থাকি। এই ক্ষেত্রে সমাধানটি পাওয়ার সিরিজের আকারে আসবে, তাই আমরা এই সমাধানগুলিকে পাওয়ার সিরিজ সলিউশন বলছি। মিন্স here the general solution will come in the form of a power series. That's why it is known as power series solution. In this video, I will discuss about the power series solution of a differential equation about an ordinary point. And in the next video, I will discuss power series solution of a differential equation about a regular singular point. Now, to start the process, first I want to introduce or I want to inform what is power series. Power series কি? পাওয়ার সিরিজ হলো একটা ইনফাইনাইট সিরিজ যেটি দেখতে এরূপ হবে, অর্থাৎ summation n equals to 0 to infinity cn first bracket open x minus x naught whole to the power n equals to c naught plus c1 x minus x naught plus c2 x minus x naught whole square plus c3 x minus x naught whole cube plus dot dot dot. Here c0, c1, c2 dot 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 c3, these are all constants, and this x0 is our main thing. This will be ordinary point or regular singular point. The definition of ordinary point and regular singular point I will discuss just later. If any series be of the form, this is short form, this is the bigger one, then we say that this series is an infinite, the series is a power series. Like e to the power x is 1 plus x square by factorial 2 plus x cube by factorial 3 plus dot dot dot. It can be written as summation n equals to 0 to infinity x to the power n by n factorial. This is also a power series. Here x naught is 0 and c naught is 1, c1 is 1, c2 is 1 by 2 factorial, c3 is 1 by 3 factorial, c4, which I have not written, is 1 by 4 factorial, etc. Now this part is not related to our discussion, though I have written the above power series. উপরের এই সিরিজটি কে আমরা কনভার্জেন্স বলবো। The series will be convergent if mod x is less than r, where r equals to limit n tends to infinity modulus cn by cn plus 1, provided the limit exists. Capital R is said to be the radius of convergence of the power series. Open interval minus r2 plus r is said to be the interval of the convergence. Means this capital R is called radius of convergence. The definition of capital R is this: cn and cn plus 1 are nothing but the coefficients. These are all okay. And first we have to calculate this limit if it exists, then if mod x is less than r, we say that the series is a convergent series. And this open interval minus r to plus r is known as the interval of convergence. Now come to the point, ordinary point. A point x equals to x naught is called an ordinary point of the equation d2 dx2 plus p of x dy dx plus p of x y equals to 0. If both the function p of x and q of x are analytic at x equals to x naught. Now what is analytic function? Analytic function কি? আমি আমার এই ভিডিওতে অ্যানালাইটিক ফাংশনটি নিয়ে ডেফিনেশন বা আলোচনা করিনি এই কারণে, কারণ অ্যানালাইটিক ফাংশন একটি বড় অংশ, সেটা নিয়ে আলোচনা করতে হলে আমার ভিডিওটি অনেকাংশে বড় হয়ে যাবে। তাই we just keep in mind that analytic function, any function or a function is said to be analytic if it is differentiable. Okay, means the function p of x is said to be analytic at x equals to x naught if the function is differentiable at x equals to x naught. This is not the actual definition, but this is the corollary of the definition of analytic function. Okay, right? So what is analytic function? Any function is said to be analytic at the point x equals to x naught if the function is differentiable at that point x equals to x naught. Now, singular point is if the point x equals to x naught is not an ordinary point. When it is ordinary point, if p of x and q of x, these are function of x alone or constant. It cannot be a function of y. Means there will not any term involving y, right? Now p of x and q of x, these two are said to be analytic if they are differentiable at x equals to x naught. If they are not analytic, then what? Then they are called singular points. Okay, means if differentiable, then analytic. If analytic, then this is ordinary point. If not analytic, then this is singular point. Now, if x minus x naught into p of x, very very important, okay? If x minus x naught into p of x and x minus x naught whole square into q of x. Just remember, here first order x minus x naught p of x, here x minus x naught whole square q of x. If these two functions are analytic at x equals to x naught, then the differential equation, then x equals to x naught is known as regular singular point. So if p of x and q of x are analytic, then they are said to be ordinary. If p of x and q of x are not analytic, then they are not ordinary point. And if they are not ordinary point, then they are singular point. Now come to singular point. If singular point, then x minus x naught into p of x and x minus x naught whole square into q of x. If these two functions are analytic, then it is called regular singular point. Okay. Now I have given here one example to define this whole thing. আমি এখানে একটি উদাহরণের মাধ্যমে ব্যাপারটিকে বোঝানোর চেষ্টা করেছি। বলেছে determine whether x equals to 0 is an ordinary point or a regular singular point of the differential equation this. So it is given 2x square plus 2x square d2y dx2 plus 7x x plus 1 dy dx minus 3y equals to 0. To make it like this, d2y dx2 plus p of x dy dx plus q of x y equals to 0, I divide both sides by 2x square. So the equation becomes d2y dx2 plus 7x into x plus 1 by 2x square dy dx plus minus 3 by 2x square y equals to 0. Compare this with the general form of second degree of differential equation. We get p of x is 7x by 7x into x plus 1 by 2x square, that is 7 into x plus 1 by 2x, and q of x is minus 3 by 2x square. This is our qx and this is our p of x, right? Now to verify the function or the point x equals to 0 is a analytic point or not, we have to do derivative of p of x and q of x. Here I have calculated limit of the function p of x and q of x. Limit x tends to 0, 7 into x plus 1 by 2x, and limit x tends to 0, minus 3 by 2x square, means limit of p of x and limit of qx square at the point x equals to 0. This is the point. Since p of x and q of x are not differentiable at x equals to 0, because this limit does not exist because of this x, Also this limit does not exist because of this x, because this limit will be infinity, this will be minus infinity. So limit does not exist. As limit does not exist, we can say the functions are not differentiable, and as they are not differentiable, they are not analytic, and as not analytic, the functions are not ordinary point. So you can say that x equals to 0 is a singular point. Now we already know that x equals to 0 is a singular point. Then we have to show, or we have to verify whether the point is a regular singular point or not. To do it, we find limit x tends to 0 x minus 0 p of x, that is equals to 7 by 2, and limit x tends to 0 x minus 0 whole square. Here power is 1, here power is 2. Q of x, that is equals to minus 3 by 2. Means both the limit exist. So we can say that x minus 0 p of x and x minus 0 whole square q of x are analytic x equals to 0. As they are analytic at x equals to 0, so we can say that the point x equals to 0 is a regular singular point. So first one is p of x and q of x are not analytic, therefore they are not ordinary point, therefore they are singular point. Then we do these two things, x minus x naught p of x, x minus x naught whole square q of x, at where at x equals to x naught, this is our x naught 0, and as they are analytic, so we say that the singular point is a regular singular point. Now we have to find, or we have to solve an ordinary differential equation of order 2 about an ordinary point x equals to x naught. Suppose this is the technique. See, let the given equation be d2y dx2 plus p of x dy dx plus q of x y equals to 0. Means I have considered here second order ordinary differential equation. Okay, this d2y dx2 can be written as y double dashed plus p of x y dashed plus q of x y equals to 0. If x equals to x naught is an ordinary point of 1, then 1 has two non-trivial independent power series solution of the form. তো আমি এখানে যে টেকনিকটি তোমাদেরকে বোঝানোর চেষ্টা করছি সেটি তোমরা বোঝার চেষ্টা করো, এটাকে মাগ আপ বা মেমোরাইজ করার চেষ্টা করো না। If x equals to x naught is an ordinary point of 1, then 1 has two non-trivial independent power series solutions of this form. Right? This is our power series form, x minus x naught whole to the power n. So let y be this function. Then we have to find this cn. Cn means c0, c1, c2, c3 dot dot dot. Now I have differentiated this equation twice, we get this and this. Okay, and using these values of y dashed and y double dashed, where in equation number 2 here, in place of y double dashed we use this result, in place of y dash we use this result, in place of y we use this result, and after putting the values of y double dashed, y dashed, y, we simplify all of them and the equation will reduce to this form, where the coefficients of a0, a1, a2 dot 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 an are etc. all some functions of the coefficients of c0, c1, c2 etc. By comparing on both the sides, we get a0 is 0, a1 is 0, a2 will be 0 dot 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 n will be 0. Now we have to solve these all equations and we find the values of all the coefficients in terms of any two coefficients. Now the question may arise, why two coefficients? Actually, this is an ordinary differential equation of order 2. 2 means the general solution will contain two arbitrary constants. So we have to find the coefficients c0, c1, c2 dot 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 cn in terms of any two fixed coefficients among them, and that two coefficients will be our arbitrary constants. এই ব্যাপারটিকে বোঝাবার জন্য আমি একটি এক্সাম্পলের মাধ্যমে পুরো প্রসেসটিকে স্টেপ বাই স্টেপ করে তোমাদেরকে বোঝানোর চেষ্টা করছি। Find the power series solution of the equation x square plus 1 y double dash plus xy dashed minus xy equals to 0 in powers of x. In powers of x means here about x equals to 0. So we have to find the general solution of this equation in the form of a power series. Means the result or the general solution will be in the form of a power series, right? So just write down the equation and dividing both sides by x square plus 1, the result will become this form. Clearly, this is our p of x and this is our q of x, right? Now we have to find p dash x and we have to find q dash x, right? So p dash x is this thing. Now here the point is x equals to 0. It is already said that x equals to 0 is the ordinary point because it is given about x equals to 0. About x equals to 0 means about ordinary point x equals to 0. Now I have tested here p dash 0, which is 1, means finite number, means we can say p dash 0 exists. Similarly, though I have not shown here q dash 0, but the result will be minus 1. Okay, you can check. So both the results exist means they are finite. So we say that p dash x and q dash x exist. That is, p of x and q of x are analytic at x equals to 0. So we say that x equals to 0 is an ordinary point. Now we choose the solution of the given equation be of this form: y equals to c naught plus c1 x minus 0. Just remember, x minus x naught plus c2 x minus x naught whole square. Here x naught is 0. Here our x naught is 0. Then plus c3 x minus x naught whole cube. The next one will be c4 x minus x naught whole to the power 4 plus so on. As x naught is 0, the result will be y equals to c naught plus c1x plus c2x square plus c3x cube plus dot 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 dot. Now we have to differentiate this equation, or means equation number 2, twice. Now why twice? Because we have y double dash, means second order derivative, first order derivative. If the equation is a third order equation, then we have to differentiate thrice. After differentiating 2 with respect to x, we obtain y dash is this result. I am not defining differentiation because I know you already know this. তাহলে আমাদের এখানে y dash হলো c1 plus 2c2x plus 3c3x square plus 4c4x cube dot dot dot. Mark this as equation number 3. Again differentiate 3 with respect to x, we get this. Now we have to use this results. Now we have to use this results, means y dash, y double dash and y. What? Now we have to use this results y double dash and y dashed, this three results, equation 2, 3, 4, in our main equation, means equation number 1. So I have put here the values of y dash, y double dash in equation number 1, and simplifying, just see, simplifying, we get x square plus 1 into this plus x into c1 plus 2c2x square plus 3c3x cube plus 4c4x to the power 4 plus dot 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 minus c naught x plus c1 x square plus c2 x square dot dot dot. After that, we rearrange them according to the power of x. See, this is x to the power 0, then x, the coefficient of x in one bracket, then x square, the coefficient of x square in another bracket, then x cube, the coefficient of x cube, then x to the power 4, the coefficient of x to the power 4. Do it very carefully because the method is quite lengthy. Though it is a easy method, but the method is quite lengthy. একটু বড় মেথড, তাই একটু সাবধানে আস্তে আস্তে করতে হবে। একবার ভুল হলে ভুল বের করে সেটিকে আবার করা একটু পরিশ্রম সাপেক্ষ হয়ে দাঁড়াবে। তাই তোমরা খুব আস্তে আস্তে প্রতিটি স্টেপ বুঝে বুঝে করবে। আমি এখানে এক্স এর ক্রম অনুসারে সাজিয়েছি। এখানে এক্স নট আছে, তারপর এক্স আছে, তার কোএফিসিয়েন্টস গুলো একটি ব্র্যাকেটে, দেন এক্স স্কোয়ার আছে, তার কোএফিসিয়েন্টস গুলো একটি ব্র্যাকেটে, এভাবে সাজিয়েছি। এবার আমরা কম্পেয়ার করব। we do compare on both sides according to the power of x. See, 2c2 is 0, then definitely c2 is 0, Then second one, 6c3 plus c1 minus c0 equals to 0, and the result is c3 equals to 1 by 6 bracket open minus c1 plus c0. আমার কখনো ক্যালকুলেশন করতে গিয়ে যদি ভুল হয় তোমরা অবশ্যই সেটিকে কারেকশন করে নেবে এবং আমাকে কমেন্ট বক্সে সেটি অবশ্যই জানাবে। নেক্সট 2c2 plus 12c4 plus 2c2 minus c1, that will be 0. The result is c4 equals to 1 by 12 c1. খুব আস্তে আস্তে এই স্টেপস গুলোকে করতে হবে, সামান্য ভুল হলে পুরোটা ভুল হয়ে যাবে। এইভাবে আমি দেখো প্রথমে c0 0, then c3 1 by 6 bracket open minus c1 plus c0, then c4 1 by 12 c1, then c5 3 by 40 bracket open c1 minus c0, then c6 1 by 180 c0 minus 9 c1, means I have calculated here, or I have find here the values of c0, c3, c4, c5 and c6 in the form of c0 and c1, which I have already said earlier, right? All the coefficients we have to calculate or find in terms of any two among them. Here I have considered c0 and c1. In this way we have to find c7, c8, c9, c10 dot 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 etc etc. Just do up to c6 or c7, okay, because the method is already very big. Therefore putting the values of c2, c3, c4, c5, oh, c0, c1 also, here c0 is c0 itself, c1 is c1 itself, then c2, c3, c4, c5 etc in where? In the equation number 2. In the equation number 2 means this equation, or you can put here this equation, y equals to c0 is c0 only, c1 is c1, then c2 will be this, c2 will be this 0, then c3 will be this. We put in equation number 2, right? After putting, I have taken c0 as common, c0 common, the coefficient of c0 1, then this is our c0 1 by 6 x cube, then this is our c0 3 by 40 x to the power 5, then this is our c0 x to the power 60 by 180 plus minus dot 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 etc. Then c1 is common, c1 is common, first one is x, then c1 is common minus 1 by 6 x cube, then c1 is common x to the power 4 by 12, then this c1 is common 3 by 40 x to the power 5, then this c1 is common minus 9 by 180 x to the power 6 plus dot dot dot. So see, this is the general solution, and the general solution is in the form of a power series. That's why it is called power series solution. Here the solution contains exactly two arbitrary constants c0 and c1. Also we see that the given differential equation is of second order differential equation, so number of arbitrary constant equals to order of the differential equation. So this is our required general solution, where c1 and c2, where c0 and c1 are parameters. So this is all about power series solution of a differential equation about ordinary point. In the next video I will discuss about power series solution of a differential equation about regular singular point. Now I have given here 4 examples or 4 homework. Do these homeworks by yourself, and if you face any problem let me know in my comment box. Thank you.